Okay, SAC Module 3, skills you need. We're going to look at, well, you will have to be able to read an XML document. From the structure of the XML document, you will need to be able to create data structures for storing the contents of the disk file in RAM for processing. You're going to have to do some searching, binary searching, because of the data size of the data set. And also because you're going to use binary search, you're going to have to use a sorting algorithm. Okay, and the sorting algorithms that you need to be able to replicate are selection sort and quicksort. Quicksort is a little bit more complex, so we're going to use selection sort. Okay, so I've just created myself a bog standard forms app there. I've loaded the data for this. It is the books.xml. I've loaded that inside the debug folder of the bin of my project. And you can give it a fully qualified path name if you want. That's absolutely fine, but I think the easiest way for testing is to put the data file inside the application itself. And that's pretty typical, actually, because if you've got data that an application needs to use, like system data, then you would generally store it with the application. There would be some way of updating that as well. I'm just going to check how much battery I've got. I'm okay. Okay, so, all right. So here's the XML document we're going to process. Now, okay, and this is not going to be a discussion about XML, but we will talk about it in some shallow way. You know what a CSV file looks like. So a CSV file is each line of the CSV file represents an object. It models an object. And those fields, we've learned how to take those fields that we read and store them in records, and each record is then stored in an array of records. The comparison between CSV files and XML files is in terms of efficiency and effectiveness. Well, in terms of efficiency, the only things that you can consider in terms of file storage and processing time is efficiency, is size. And if you consider the data that we're representing for each record, in other words, each line of our CSV file would contain these pieces of data, so there'd be 1, 2, 3, 4, 5, 6 pieces of comma-separated data, you can see that an XML file has a big overhead that's related to the tag structure that's used to contain the data or represent the data. So it means that the file storage of an XML file is considerably larger. There is a penalty, and also that means that there is certainly a greater latency in terms of upload and download speeds, file reading and file writing. So what's the purpose of using an XML file as opposed to a CSV file? Well, CSV file is a really simple file format to create. XML is quite complex to create. You see that the structure has to be very well, it has to be well formed. It's like XML in that way. There is a tag structure. Here there's the author tag, there's the closing author tag, the title tag, the toting data tag. So they are much more complex to arrange. The advantage of XML files is that they are very good for sharing data between applications because they are a standard. Developers can extend the tag set themselves. So we will use it in that sense, but they are not a file storage medium, they're a file transfer medium. That's their strength. Okay, so all right, here's our little application. Where is it? So where to go? Come back here. All right, so there we are. There's my form, and what we'll do is we'll load. I'm just going to double click on the form itself, and I'm going to add a form load thing event, and we're going to load the data into our data structures when the form loads, which is exactly the same process we did with the CSV file. And here's the algorithm you'll recognize from the CSV file. There's an index. There's a repeat until end of file, which means read every line in the file. And we're going to read the attributes, including author, ID, author, title, and the rest of them as well. I'm going to create a book object, and then I'm going to load the fields or set the fields of the book object with the data that's read from the disk file. Then I'm going to store that book object in the books array and then increment the index. That's our algorithm. It's exactly the same for the CSV file. Okay, so the data structures. Well, we're going to have to create a record. Okay, record, and I'm going to call it a book, or class book. And the fields of our class need to be public. Now I'm going to model them in the order that they appear in an XML file. Well, the first one is, what is the first one? Okay, well, if you have a look here, the first piece of data that's associated with the book is the ID. The ID is an attribute of the book element itself. Each of these are called elements, and I probably should have discussed that. We've got a root element called a catalog. It's a catalog of books. Each book there's a book element there. The book element contains an attribute, which is its ID. Not an uncommon way to arrange the data. It could have been a child element, and there are 1, 2, 3, 4, 5, 6 child elements. There's an author element, a title element, a genre element, price, published date, and description element. So there are those 6 elements. So whether we convert the data, all data in an XML and CSV file, as you know, is text. So we would probably want to store our ID as an int, because we are going to use it for searching and sorting. Public string, it's not name, it's author. I'm going to leave the, I'm going to change that. I know it likes capitals, but I'm going to change that to lowercase. It'll probably make it angry, but that's okay. Public string, it still wants to do name. Okay, what was it? Author, title, I think it was. Public string description. There is a description, so I'm going to leave that one. Public. It's taking a good guess at these. String. No, it's given up now. Genre. It doesn't know what else to call it. Genre. I think there was also a price and there's a published date. So public. Double price would be a double. I guess it doesn't need to be, because if we're just representing it as data, if we're not doing anything in terms of calculations, we could leave it as a string. But so we leave it. We may as well convert it. Whether you convert at storage time or runtime or processing time doesn't really matter. And the final one is date, public. And date is a format. It is a data type in C#. We know that, but it's not. It's not a VCAR. I'm just going to call it date. Right, that'll do. Pub date. Okay, that'll do. Right. Oh, actually no. I'm going to use our naming nomenclature, naming style. I'm going to call it published date. Doesn't matter. You can call it whatever you want. There we go. All right, published date. All right, if I could spell it. All right, so there's our record, or there's our record to model the data that's read from the DIS file. Now, in the SAC, you will have to look at the data, and you will have to determine what the internal structure of your record looks like. And we're going to create an array of books, and I'm just going to call it books. And we'll set it to null. So we've declared it, but we haven't given it any memory. We can't. It doesn't make sense to give it memory at the moment because we don't know how many books are in the catalogue. We do. We could cheat, but that wouldn't work for us. Okay, so now you will need to include the XML library. I don't think I need IO, but you will need to use using system.xml. That'll give us access to the XML libraries. Okay, so the first thing we need to do is create an XML document. And this is going to, well, there we go. We'll just call it document. And that will be used to hold the structure of our XML document when it's read from memory. In the same way that when we read a CSV file, it's stored as an array of strings. Okay. So when I'm going to have to load the document. So I've got to tell it to read the document. What's ours called? Books.xml. Now it's a string. And it must be the full name, including the file suffix, the file handle, the file type. And then what we're going to do is we're going to use the doc from that document when it's read. And right, okay, so I should actually check that that runs now, so that I can see that it actually does find the file. If you get an error now, you know that the file's in the wrong place. So it's done it. It's loaded the document for me. That's cool. Got this thing up here. I've got to shift this. All right. So now it's read the document for us, so we're good to go. So what we've got to do now is essentially parse the document the same way as we did with the CSV file. But because the tags are named, we're able to do that in a much simpler way. So if I do doc.get elements by tag name. Well, each of the tags has a name. Now the element that we're after has the tag book. We want to read the data that's associated with each book. So there's the data that's associated with my one book. If I collapse it, there's my book. It's got an attribute ID and it's got an author, title, genre, price, published date and description, child elements. These are each nodes. This is the catalog. This is the root node or the root element. This is the book node or the book element. Each of these are child nodes or child elements. Okay, so what this should do by now, if I put my cursor over this, it says it returns an XML node list. Well, let's create an XML node list to store it in. XML node list. Okay, and let's call it XML book list. That'll do. It's an easy name. XML book list. That'll do. So what I should find now is when I run this, I should find that I've got 12 books in here because that's how many are in the XML file. There it says count 12. Now, when you start to look at this, you should be able to work out that, again, that these elements are actually stored in arrays. So now that I know that I've got 12 of them, so I can go and size my book array. So I'm going to do books equals new book and the size of my book list. In other words, so now if I run this, what I should find is I've got an array of 12 books that have nothing in them. There's my 12 books, okay? Numbered 0 to 11, 0 to n-1. 12. Okay, so now what we need to do now is loop through each of the books that are in the XML book list and pull them apart, store them in their own book object and pack them into the array. So we could use a for loop as we did with the CSV file, but another way to do it is use a for each loop. And they're pretty cool. They're really nice, elegant structures. So I'm going to use a for each. Now these are also an algorithmic, VCAL loves these as an algorithmic thing. So there we go. So what it's saying is that for each of the books, for each object in my XML book list, it's going to capture it as an XML node. Well, the XML node will be this book node here, this first book node. So it will load all of that data into this one XML book node. We'll do it one at a time. It'll iterate through all of the items in our book list there. So what I need to do now is I'm going to create a book, the book equals new book, and I'm going to pull the data out of that XML node and store it into the book, the book. Okay, there we go. All right, so now, when we did it in our CSV file, we just went and got CSV, the line 0, the line 1, the line 2, the line 3, just accessing them. So we would do this, book 0, and so on, So we did this, the book. Oh, no, look, I can't really do it. But anyway, so what we're going to do is, because we're using an XML document, we can use the tag names to capture the data. So the first thing we want to do is get the book.id. And that's going to be set to equal to XML book, there it is. It's come up with it for me. So in my XML book, it's got an array of IDs. Now, in our array of IDs, there's only one. If I put another one in here, if I put in another attribute in here, I could put in another attribute by putting a comma, then there would be one more item in our array. But it's going to the attributes and it's going to find the attribute with the name ID. Now, this is a string. We need to convert that to an integer. So now I'm not going to do any validation on this. I'll leave that to you at some stage. Int 32. So let's just go. We know. So it's a string already. So what it's gone and done is it's retrieved the value associated with the attribute called ID. So that will be the number or the string 1011. And we're going to convert that to an integer. So if we run that now, what we should find is at the end of this, our book has an attribute inside it. Come on. Oh, no, it's because I've jumped outside it. So if I continue, let's run that again. It's always good to do this just to check you're on the right track. If we look in the book now, there's no other data, but we do have an ID of 1011. So that's worked. So we've captured the data. Now it's exactly the same process. We're going to do the book dot what was the next one? Author, I think, equals XML book, and we want to go and get the tag that's author. So all we need to do is we're going to use the XML book is a list of books. So it says there string the name of the node. Well, the name of the node we want is author. All right. Now we need to go and get, that will be the node itself. What we need to do is get the text that's inside that. So that's going to be inner text. Okay, so this will go and get the inner text from inside the author tag of the first book in our catalog. So if I run this now, what we should find is the book has two items loaded. There's the author and there's the ID. Okay, so we can just carry on and do exactly the same for all of our other attributes and all of our other elements. So the book dot title, there we go, and it's worked out how to do it. Dot description, there we go. The book dot publish date. Does it get this one? No, XML. Some it doesn't get. Oops. What did I say? Publish date. Now, it is like, how can I put this? But just inner text would do me. Okay, publish date is just a string, isn't it? I just had it as a string, so yeah, what's it on about? Anyway, it doesn't matter. So what have we got now? So what other ones? Oh, genre we need to do, don't we? So genre, the book dot genre equals, it's cracked it with me, XML book genre dot inner text. Get the text from there, and the final one. Oops, hang on. I've got to. It's got to go inside. It's a string. My bad. Okay, and the final one is the price, isn't it? The book dot price. Now again, the price we're probably going to convert to double, and it's going to be XML book, and it's going to be the price tag, and we're going to get the inner text from there. Okay, so that's all right. So let's see what we've got. Just check that all converts through nicely. And does it please run? No. What have we got? Oh, good one. So no, to double. Yeah, obviously. Double. So let's run that again. Alright, so let's check it out. So there's our first book. There we go. So there's all the data. We've captured all the data, loaded into there. So the next step in our algorithm is to put it into the array. So books index equals the book, and then you've got to do, and we've got to do index plus plus. Do not write index plus plus like an algorithmic statement in the exam. It must be index equals index plus 1. So, right, a couple of things to notice, that these are using array syntax, but not with an integer value. They're using a key. This is using key value pair. This is using a dictionary of items to access an array. Dictionaries, associative arrays, hash tables, all use arrays in the background. I'm lying, but that's okay. So instead of using an integer, we know that this is using a dictionary because it's using a string. This is the key. The value is the inner text that it finds inside there. Okay, we'll talk more about that later. Okay, so what we've captured our data. Now, to search the data, we're going to search on node ID. But to search on ID, we're going, because there are millions of books in this collection, it's a massive library. We're going to use a sorting procedure. If you're going to use binary searching, it's unsafe to make the assumption that the data is sorted, because if the data has been modified since it was last accessed, in other words, if some data has been added, it may no longer be in sorted order. So it's not really safe to assume that the data is in sorted order. So we are going to sort it. Okay. The algorithm for sorting. The algorithms for sorting you need to be aware of are selection sort and quick sort. The difference, well, quick sort is quicker than selection sort. The other difference is in terms of not algorithmic complexity, but in terms of how complex the code is to write. If code is more complex to write, there's a greater chance of it being containing errors. So, it was a VCE exam question. Fred wants to use quick sort, but Janice recommends that he use selection sort. And the reason is that Janice doesn't think Fred's a particularly good programmer. All right, so selection sort, the algorithm works. We're going to look at one pass at a time. Each pass finds the smallest item in the unsorted data and puts it in the correct position. The correct position is at the start of the unsorted data. It then increases the size of the unsorted data, or decreases the size of the unsorted data by 1, and increases the size of the sorted part of the data by 1. Okay, so we won't do it on the data to start with. Let's just create, I'm going to come up here and just do a void selection. I'm just going to call it selection sort, and I'm just going to code the algorithm. We'll give it a crack at coding the algorithm, just using an array of integers. All right, so each pass, all right, we've got to, we need to manage a bit of data. We've got to remember where we start. So start is going to be set to be equal to 0. So it's the start of the unsorted data. Well, when we start, in our first pass, there is nothing in the sorted part, so the start of the unsorted data is index 0. We've got to remember the position of the smallest item. Let's call that pos smallest. And that's going to be set to start. Right. That's, the smallest one that we know in the unsorted data is the first item of the unsorted data. Okay. All right, then we're going to loop through. So we're going to use a for loop. For int I equals 0, I is the start. Okay, there we go. So that's going to loop through all of our data. And we're going to compare. We're going to say if the item, actually, I is not going to start at 0. I is going to start at start, because that's where we want to start, at the start of the unsorted data each pass. So what we're going to do now is we're going to say, okay, we're going to say, hey, listen, if item I, if the value at I, if data I is less than, not that one, data, the position of the smallest, pos smallest, if it's less than that, we're going to update where we, come on, play nice. What's going on here? No, don't do that for me. So we're going to say, we're going to update, there we go. Not update data I, we're going to update pos smallest to be I, because we know the data at index I is smaller, smaller than the element at data pos smallest, which we initially believed to be the smallest item, or was the smallest item we knew. Otherwise, do nothing, just go to the next one. At the end of that, we've got to swap it. So if let's just create some data here, int data equals, and if we just do it in the most unsorted order, 9, 8, 7, 6, 5, 4, 3, 2, 1. And you can bet your life I'm going to get this wrong, but that's okay. All right, int array, yeah, good one. Okay, all right, so now if I just put down the bottom here, we'll just run through, just get this to work using just an array of integers. Selection sort, is it going to work? Yeah, there we go. Selection sort, and we'll just give it data. Okay, so what I should find during the first pass of this, at the end of this, it should show me where the value of the smallest item, where the value of the smallest item in the array is, which I'm hoping is going to be, I don't know, what is it, the last one. Yeah, move on. Come on. Let's get rid of that one. All right, so let's see what is pos smallest. I need to shift the breakpoint down to here, and I should find that with a bit of luck, pos smallest is 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's found where the smallest item is. So that's working. So now what we need to do is swap. Now, you can optimize the swap routine slightly. We're going to say if pos smallest does not equal start. In other words, we're not swapping this. If the smallest item is not in the right place already, swap it. And we need a temporary integer, temporary item to hold our thing, and that's going to be, what are we doing? Data, sorry, Ethan, data, start. And you can do this either way, it doesn't matter. I just do it this way, and data started with pos smallest, and then finally pos smallest equals temp. There we go. Okay, so now if I run it again, what we should find at the end of this, hopefully we end up with the smallest item in the start of the array. Please be right. Yeah, there we go. All right, so now, after one pass, all we know is that the first item is correct. After two passes, the first and second items will be in the right place, and so on. Each pass puts only one item into the right place. All right, that's all we know. All right, so what we've got to do now is actually iterate through this entire thing, the number of elements there are in the algorithm, in the data. So I'm going to put all of this inside int. Okay, I'm going to do int start equals 0. And I'm going to do start. All right, there we go. Now, I can't, all right, I've got to take that out. I've got to take this out because I'm including all of this inside this outer loop. So now what I'm doing is I'm iterating through start from 0 through to the end of my array. Okay. Let's see what happens. What can go wrong? A lot. Please work, please work, please work. Yeah, okay, there it is. All right, so there it is. It worked. All right, so now that's a generic selection sort algorithm. Can we optimize it? Yeah. Instead of starting at 0 and 0, we could do it start equals start plus 1. You know, you're going to do one less comparison. That's all. Did you get it? So if I start there with start equaling 0 and I equaling that one, I'm comparing those two. Initially, I'm comparing 9 to 9, and we know that they can't be different. So let me see that still works. Let's hope it does. Should work. There we go. Okay, so that's, wow, you know, you can see that was so much quicker. Yeah. That one less iteration made such a difference. Now, okay, so we want to sort on the book ID. So if let's modify this. So I'm going to change this to be not an array of integers, but array of books. Book, and let's call it books. Okay. Well, now the problem is that okay, well we've got to do books. We've got to change this to books. Now, books doesn't have a length, but it does. Oh, I beg your pardon. Oh, that's right. Sorry, it's array. You're right. You're right. Okay, so that's all good. That's all good. But here's the problem. All right, so where do we... All right, let me get rid of... I'm going to ditch... The reason why this is still not showing as many errors as it should is it can still see this. So I'm going to comment that out. Now it's going to crack it. All right. So you can see the problem now. So, well, this has got to be the same thing. We've got to change this to books. Okay. Now, and this has got to be, okay, books I to books. Possible. The only problem is that if books I is, well, books, there's no way in the world it can actually work out what, you know, how is one book bigger or smaller than another one. We've got to get the ID out of the book. So it's going to be this. So this is a book. At books I, if I equals 0, books I is a book. Well, we can get the ID of that. There we are. Dot ID. And think about it. This is a book. I'm getting the ID of the book. I could do this. Book B equals books I, and then I could do B dot ID. That's the same as doing this here. It's exactly the same. I've just done it in one line, and it's a lot easier. Then I update the, right, and then now it's down the same here. Now, inside our book, so let's do this again, books, and you know, I know that there's errors still. That's okay. Now, but we can't store a book in an integer, so we've got to store a book in a book. Okay, book. Okay. Now, all right. So does that seems to be it. So now let's come down here and do this. Sort the books. Let's see if this again. Let's see if this holds true. See if it works. All right, no errors, but that doesn't mean it's worked. Let's have a look. So 1001, 1003, 1005, 11, 12. I'm going to assume that, well, I'm going to assume that it got it right. There you go. Okay, so that worked. So it's completely scalable. If we change this, if I want to add a book to this, it's very simple to do. So because if you've got this open in your XML project, so if I come down to the bottom here, come down to the last one here, if I want to create another book, all right, I'm just going to put in a new line here. I'm going to create a book tag. All right, there's my closing book tag. I'm going to have an ID in there. ID, an attribute equals, and it must be in a string, so it must be in double quotes, the string. 999. No, I'm going to make this the smallest one. 0000. That'll do. Oh, yeah, that'll do. That's pretty small. Now I could put in an author tag. All right, there's my closing author tag, and let's put it me. Let's put in the title. Whatever. I don't know. That'll do. Can't be bothered doing anything else. Genre. There we go. Price. Now, the same things apply in terms of validating your data. If my price was not numeric, then I would get an error in when I try and process the data. Published date. You'll notice that I use a different naming format in XML files. You don't have to. Published date 6. oh, it doesn't matter because I'm not converting that string into a date and description. Okay, so if I save that and let's run this again, let's see. I got it wrong. Publish date in a text. What did it do? Did I malform the XML? Let me see. If the XML document is not well formed, come on, what's wrong with that? Did I misspell something? It's quite possible. Let's have a look at that code. If it doesn't, if I can't obviously see it, I'm backing out of this one. Let's see. Maybe genre is null. Okay, publish date in genre. Now, why didn't it read the genre? That's oh, probably because I haven't asked it to yet. So let me just copy this one down here. I can't see anything definitively wrong with it. Now let me just run that again. And let's see what we get this time. Okay, so I have no idea why that cracked it. It doesn't. Yeah, I probably should. I'll have a look at it later. But what I should do now is let's see that what our first book is. There you go. Works fine. Okay, so you can see that you can modify the XML document. But look, XML documents are not bulletproof. If there's an error with the data between the data that you're expecting or the data the application solution is expecting and the data that's provided, then it will still present a problem. So let's have a look at how we can do a search on that. So if I come back into my design and I come into the toolbox and you know that you can put in, so let's just look at all Windows forms. Let's just put in a button, a search box. Where are we? Text box. Why isn't the text box? Why doesn't it have text box? No, I don't know. Text box, I don't know why it's not there. Okay, it doesn't matter. Okay, so I'm not going to bother naming them. Oops, that's cool. So there's my button. I'm not going to bother naming it. I'm just going to input ID and then search. Okay, so we'll need a binary search. So it's going to be, we're going to return the index to it. Binary search algorithm, and you're going to give it the data you're going to search, and it's going to be in the books array. Books int start, no, int ID. Okay. So we haven't returned anything. So let's do int index. Yeah, that'll do. Is the finally. Okay. All right. It's going to use a for each loop. You can use a for each loop. I'm going to do a while loop. While index is less than books.length. Wow. All right. No. Come on, get out of here. We're going to do int left, because we're using a binary search. Left equals 0. Int right equals no. Books dot length. Okay, -1. Okay, because we know that we've got to maintain those 2 pointers. And we're going to do while left is less than or equal to right. If I get this wrong, it's just going to fix it up. And we're going to just do a check, comparison if, oh no, we've got to calculate the midpoint, don't we? Int mid equals left plus right divided by 2 if books, okay, books mid, let's get the book that's at the mid, get its ID, equals, if books mid ID equals, let's do, we should do this target ID, yeah? Target, oops, hang on, where did that go? Target ID, target ID. Okay, then we found it, so all we need to do is return, well, mid, right, that's where we found it, go back. Else we've got to work out whether it's likely to be the left or the right of it. Else if books mid ID, books mid ID is greater than target ID. So if the mid ID is greater than the target ID, it must be to think about this. If the mid ID is greater than the target ID, it must be to the left of it. So we're going to say that no. Right equals mid minus 1. I think that's right. So let's think about this. If the mid ID is greater than the target ID, yep, it's got to be to the left of it. So we're going to bring the mid point, the right pointer down to mid minus 1. Else, oh man. Else left equals mid plus 1. Okay, and right, there we go. And we know that if we reach down to here, it must not be in there, so we're going to return minus 1. Okay, so now the places where it could go wrong are here. I'm not sure, I can't remember this less than or equal to, or whether we've got these around the right way. The way to test it is you're going to have to test look for the first item, the last item, and a midpoint. And you should also check, there are a few others you should check for, but that should do it for us. So let's go do it. So selection sort, let's just do binary search. So input ID, so what do I say? Int index equals input, what do you call it? Text box 1 dot text, and we're going to have to convert that to a integer. And again, you need to validate this. 32. I'm not validating it. I'm not validating for existence. Data type range, you wouldn't need to, but certainly you would need to do it that. Then we're going to do int index equals, what is it, binary search, and we're going to give it books and our index. Oh, no, we can't call that index. Let's call it target. Okay, so we'll look for 1001. Yeah, I know that one exists. So let's do that. All right, yeah. When should you sort? Depends. 1001. Index is -1. Okay, so we didn't find it. So let's find out why we didn't find it. We better actually have a look at that and examine the algorithm. Let's see. I'm assuming there. Oh, okay. Well, that will be why, because I typed it doesn't exist. So let's see that it does find it. All right, continue. So books mid ID is greater than that, certainly greater than, so we're going to, all right, left, what's left? Left is 0, right is 5. And let's find out where it is actually, 1001. Is that the second one? Yeah, so that's index 1. 3. Okay, so mid is 0, so alright, so return mid, okay. It's found it, okay, so it did work. I just didn't type in the right one. So it found it, so if I wanted to output the data or do something with it, I can. I know that it works. Okay, so look, we haven't done any processing on it, but the skills you need to be able to do, you need to be able to determine, you need to be able to read an XML file. Reading the XML file, there it is, bog standard. There's the data to read an XML file. Now this will need to change. This will need to change. The name of this would need to change. You know, but you will need to have, by that stage, you must have worked out a data structure to store the data. So a record to model the object you're reading from the file, and an array of those objects to store the objects in. Then once you've read that data, and once you've parsed it and packed the data into the data structures, sorting, when you sort, that depends upon if the data is changing. You can't, you know, if the data is being refreshed on a server, then the server would have to contact you and say, listen, the data's changed, here's the new data, resort it. Maybe the server sorts the data. That would be a more sensible approach. But anyway, you're not dealing with that. And then it's a question of implementing a selection sort algorithm. Selection sort algorithm, you will need to understand how it works. For completeness, I think the understanding of this part first, that's one pass, and then a swap if needed, and then encasing or encapsulating all of that in a loop that iterates from 0 through to the number of items in the array, so n minus 1, I beg your pardon, and then perform a binary search on it. But the skill is accessing data using fields of records. This is accessing the data by indexing an array. This is accessing the data inside that record by using its field. And that is it. Okay? All right. See you later.